Welcome back, ladies and gentlemen. Today we're going to talk about section 11.4. It's all about circumference. Up on the screen, you'll see your exit question for the day. It's a good one, so I'd suggest reading it now, freaking out a little bit, and then coming back to it later when you hopefully can answer it. We're starting a new chapter today, so that means that we are most likely going to start with some new vocabulary, and that is absolutely the case here. Although it's probably not new vocabulary, it's vocabulary that you already know, just maybe defined a little bit differently. First, circumference, the distance around a circle, and arc length, something that you probably haven't played around with too much up until now. We're going to be dealing with it quite a lot now, which is a portion of a circumference. Then, of course, there's our favorite number in the world, pi. An entire book can be written about pi and its history and all that, but you need to know that pi is the ratio of a circle's circumference to its diameter. So in other words, if you measure the distance around a circle and measure the distance across the circle and divide the two, you will always get this magical ratio that is approximately equal to 3.14. You do need to know that 3.14 is an approximation. Pi is a never-ending, never-repeating, irrational number. So, moving on from there, some of your problems will ask you to round to the nearest hundredth. Some of your answers will ask you to give an exact answer. The weird one that you're not so used to is getting an exact answer. That means that you need to leave the symbol pi in your answer. So if you were to round it off to say 12.56, that would not be acceptable. You need to leave it as 4 pi. Okay. However, sometimes you will be asked to round it to the nearest 100th or nearest tenth or whatever it is. And then we also have problems that have multiple steps. So if you round pi in your first step, by the time you get to your last step, your answer could be quite inaccurate. So what you need to do in order to combat that is to keep a long decimal working until you finally get to the very final answer that you're going to give and round your very final answer. To do that, use the pi key. The pi key will give you, I believe, an accuracy of pi that is beyond just the 10 digits or so that are displayed on your calculator. It will actually be more precise than that. Do not use the approximation 3.14 or the fraction 22 over 7. Both of those are not accurate enough for what we're doing this chapter. Use the pi key. Okay, theorem 11.8 basically describes to you how to find the circumference of a circle. It gives you a couple formulas, one that depends on the diameter of a circle and one that relates the circumference to the radius of a circle. Obviously, a radius is half of a diameter, so you'd expect a factor of 2 to pop up in one of these equations, and in fact it does. So circumference equals pi times d, or 2 times pi times r. Likewise, you need to be able to find the lengths of an arc. And to do this, the best way to think about it is an arc is a portion of a circle. So if you can find the central angle to that arc, you can do that number of degrees over 360. And over on the other hand side, the arc length that you're solving for will be right there over the circumference. And of course, you can relate that to a diameter or a radius, depending on that. But the circumference here, the portion of the circle to the whole circle, the portion of the circle to the whole circle. All right, let's jump into a couple examples here. We have a tire on top of a rim, and the question is, how many feet will that tire roll in 18 revolutions? And we have to give an exact answer. Well, to figure that out, we need to figure out how far it is around the outside of the tire, which means that we need to add up all those dimensions that were given to us, and that will be our overall diameter in 26 inches, of course. And then that, of course, we need to convert to feet. So 13 over 6 feet just by dividing by 12. So 13 divided by 6. To find the circumference, now that we have a diameter, just go pi times d, which looks a little bit like that. If you wanted to write that as a fraction in kind of vertical form, it would be 13 pi over 6. And then we simply need to multiply that by 18 to get the number of feet traveled in 18 revolutions. So the only thing that's awkward in this problem is that you're dealing with fractions again. It might have been a while. You just have to start getting comfortable with manipulating fractions, uh, not using a calculator by hand. So if you had to do this multiplication, for instance, you would write a 1 under the 18 and then find anything on top with any factors on top and bottom that are shared, and you can cross them off. Like in this case, 18 is really 6 times 3, so you cross off a 6 to get rid of that denominator, and a 3 remains up on top. The 3 can be combined with the 13, so you get 39 pi over 1, which is just 39 pi feet. These next two examples have to do with arc length, and I would really suggest pausing the video and trying to set up a proportion equation that will allow you to solve for the missing piece of information. Letter A, they want you to find the circumference of the entire circle. Letter B, they want you to find the measure of the central angle of arc RS. Now, there are only two letters, so we're talking about this side of the circle, not the other. Pause the video and try that. If you set up the proportion equations correctly, the circumference, the whole circle to the part, so they gave us the part of the circumference, the arc measurement, arc length measurement, and then they also gave us the central angle, so 40 over 360. Solve that and you'll find the overall circumference. Over here we have a radius, so using the radius we can use that to find the entire circumference, and we have the portion, the arc length portion right there, so the portion over the whole and then the portion over the whole. The portion here is missing. Solve that, and in this case they're rounding to 37.71 and 165 degrees. Next one, good one. Two gears are driving each other via a belt. How long is the belt? Interesting question. Pause the video and see if you can get somewhere on this. I would really suggest trying this on your own. All right, to do this, you have to recognize that the belt is going to peel away from the gear on a tangential path. So right here, every time this belt comes in contact with one of the gears, this is a tangent line. Now, knowing what we know about tangents, it means that this is a right angle, and if I drew another one down here, that would be a right angle. And that would make a quadrilateral, for instance, right here, where we had right angle, right angle, right angle, so therefore we have four sides. The missing angle over here must also be a right angle. Not only that, but we have two tangent lines coming off of a circle and intersecting at an exterior point, which means that these two intersections are equal to each other, and these are radii, so those are also equal to each other. Now that basically confirms that that is a square, in other words, because we have four right angles and four equal sides. So through tangent lines, what we know about tangent lines in theorem 10.2, we can assume that we have two squares. This one, same reasoning as before, which means that the length of the belt that's not on the circle right here is also 5, and 5 right here, and 2 right here, and 2 right here. So to find the total length of the belt, we take 2 plus 2 plus 5 plus 5 plus this bit and this bit. And we need to know what portion of the circle the belt is lying on. Well, we know a central angle, which is kind of nice. That central angle is 90 degrees, which means this is 270 or 3/4 or 75%, however you want to think about that. But basically what we're going to do is we're going to take those four segments that are not on the circle, add them together, and we're going to take 75% of the circumference of gear 1 and 75% of the circumference of gear 2 and add them together. We are going to give an exact answer as well. So we need to set up a proportion that's going to allow us to calculate the arc length on gear 1 and the arc length on gear 2. See if you can set those up. Those two equations look like this. So for the big gear, gear number 1, we have a radius of 5, and we want 3/4 of the way around it. So this is our circumference as a whole, and we want the 3/4 piece of it, or the 75% of it. You could replace this 3/4 with 0.75 over there if you like. Over here we have a radius of 2. It's almost identical. Cross products and solve. You get 15 pi over 2 here and 3 pi here. Now that means that you have to add 14 plus these two things that contain a pi. The 14 doesn't contain a pi, so it's going to be its own separate term, but these two do contain a pi, so you do need to combine them. In order to do that, you're adding fractions, so you need to find a common denominator. So instead of 3 pi, think of this as 6 pi over 2 by multiplying top and bottom by 2. So you take 6 pi plus 15 pi to get 21 pi over 2, and of course then you add that to your 14. So the total overall belt length is 14 plus 21 pi over 2. There's your assignment and how to complete it properly.